Uh, Before all of this, I did ask this question from the other students as well, which is the very first class. So, what's your overall idea of like learning about the physics? What exactly is the physics? Okay, something physical. Throw me some other ideas that you feel like when you say the term physics. I think you have learned a part of it for the science, for the O levels. So, yeah. Okay, okay, good. Okay. Okay, great. All right, good approach. So yeah, when it comes to the physics, so what we are basically doing is we are trying to give a numerical value for the day-to-day scenario, right? For an example, let's say if I ask how long it took for you to come from your home to here, 10 minutes. Okay. So how far is it from here? 4 kilometers. Okay, great. So which means you can give some values, right? Maybe somebody asks, okay, how far from here to your home? You can say in kind of a qualitative way, okay, it's not much. Right? Or else you can give a very quantitative idea, very good idea. Okay, this is like around 4 kilometers. So we have a numerical value there. So basically you are giving up a length in that case. And ask you, okay, how long it took? You can say, not much. Or else you can say, yeah, it took 10 minutes, like that. So in that case, if you are giving a numerical value, it gives a very good idea about how that the length and time and different specs, right? Or different physical parameters in that case. And if I ask, okay, how faster you came? What was your speed? They can say, okay, I came with a very huge speed, so that is why I can cover up that 4 kilometers with 10 minutes, right? Or else you can do some calculation. I think you can remember this equation, speed equals distance divided by time. We're gonna learn about this one eventually. So you can do a little math here. It took like it's just around 4 kilometers, and it took, you said it's just 10 minutes. So we can just say the unit to be like that, or else I can just convert this 4 kilometers to meters. It's going to be 4,000 meters because kilometers, 1 kilometer will be 1,000 meters. And of course, I can just convert this one minutes to seconds as well, if in case you multiply by 60. And I can do this one. So it's just around like 40 divided by 6, which is going to be around 6.6, right? 6 and going on meters per second. Here you can see meters and second comes up, so meters per second, right? So you can say, okay, so I came with a very huge speed, or I came with a certain speed, or else you can say I came with roughly around 6.6 meters per second, right? So giving a numerical value is what we are going to do with this physics, right? For all the day-to-day scenarios, you can see here, you feels a little bit cold in the morning. Now it's eventually getting hot. Maybe in the daytime you feel like sweating, right? So which means you can say, okay, it's very much hot or very much cold, or you can say, okay, the temperature is around 20 right now. It's around 24 degrees Celsius. So we are giving a numerical value for the temperature. And there are some other things we need to deal with. Previously, we have considered about that one. Actually, there are 7 things, 7 physical parameters that we need to mainly deal with in the learning about this physics, right? So what we are basically learning will be trying to give some numerical value for the day-to-day scenarios. In order to do that one, we need to know some equations, some sort of formula. Now, for an example here, we wrote the speed equals distance divided by time. You have learned this one for the O levels and for the physics science part. But in the advanced level, you know, at the A level, so kind of like advanced part is there. Earlier you did the O levels, which is the ordinary level. So we are going to learn the concepts in a kind of like an advanced way. And all we are learning by the physics will be some sort of equations that are dealing with giving numerical values for the day-to-day scenarios and phenomena, right? So unlike the O levels, for the A levels we have for the physics we have like 11 units. I think for the O levels you have plenty of units, right? And also plenty of subjects, just kind of 9 subjects. But in the A levels we have just 3 subjects mainly, and since you are doing the combined, so it's going to be combined maths, and second one going to be chemistry, or you can choose IT. What you have chosen? Yeah, okay, so it's going to be the IT then. Uh, and thereafter we have the physics. So even though you do the IT or whatever or chemistry, the physics is kind of like getting a compulsory subject in that case. So for the physics, uh, at the beginning, the earlier lessons I have explained that one. So the subject code going to be 01, right? I think you know about the subject codes. Different subjects have different codes. For the O levels also we had that one, and since we are doing the English medium, it's going to be 1E, right? Uh, I have given the paper structure once. I'm not going to give it to you right now, but I will, right? We can catch it up. Physics, we have 11 lessons. So you can see those 11 lessons are in the very beginning of the tude, right? So the unit 1 going to be the measurements. Basically, we are learning how the units and how we can build up the units and what are the physical quantities that we need to learn and how we can measure them up and different measuring instruments. I think you have seen one of the page that I have given you, the extra color printout that has some of the measuring instruments that you may haven't never seen before, right? Ah, okay. Okay, so that is good. Uh, so unlike the O levels, we're gonna learn some advanced measuring instruments there, especially the length measuring instruments, and those sort of things we are learning for the measurements, right? You can see the second unit is going to be the mechanics there. So in the mechanics, we're gonna learn about these kinds of things: the speed, distance, the time, and displacements, velocities, accelerations, and something called momentum, and force, the work and energy, and maybe something called rotational motion, fluid mechanics, like all the things that are dealing with something mechanical things, we can learn with the mechanics part. And the third unit going to be the waves and oscillations. In that case, we are going to learn about the waves. Now you can hear a sound right now. I can maybe speak very with a lower volume, or maybe I can speak like this very louder, right? So you can hear there's a difference with the intensity of the voice. So for the physics, we are not just saying that to be okay, it's high intense or low intense. We're gonna give a numerical value, and those things like the waves and all, like different types of waves, like electromagnetic. I think you may have heard about the longitudinal waves, transverse waves earlier for the O levels. Those parts we're gonna learn about these waves and oscillations. And also you can see that I am just wearing some spectacles to see you, right? Which means there's some uh, optic part is there, like there are how the lenses are working and different things, how the light works, and also we are going to discuss with the same part the waves and oscillations. And as I said earlier, now I told you there's a temperature right now, it's around 24 degrees Celsius, which means something to deal with the temperature and the heat, and that we are going to learn with the thermal physics, how we can measure up the temperatures and how the water and things are boiling, and how the heat energy can be used to do a work and different sort of things we are learning for the fourth unit. And fifth unit is going to be the gravitational field. Are we in a gravitational field right now? Yes, that's why if you just grab something and it's gonna fall down, right? Which means we are kind of always getting attracted towards the earth. So we are in a gravitational field. And for that part, we're gonna learn how the gravity works and how the satellite works and how rockets can be launched, different interesting things. And for the electrostatic fields, we're gonna learn about like how the charges, electric charges are working, I think you learned about like once you comb your hair from the comb, and you can stick some papers into it, which means this has some charges, and these papers also will have some charges, and like charges repels, and unlike charges get attracted, and so on, different things. And we're gonna learn about kind of like in advanced way now. If there's an attraction, okay, you know that the like charges get repelled, right? This is a plus charge and this is a plus charge, so they get repelled. So we are not just saying that they are repelling, there will be a force in that case. So we're gonna learn about what are the forces between these types of charges, and knowing some formulas to calculate them. And magnetic fields, I think you know about magnets. Like we have North Pole and South Pole, the different types of magnets. And yeah, we're gonna learn about those magnets and their behaviors under these magnetic fields. And current electricity is going to be dealing with the electricity part. You can see there are lights, and you can just turn it on and off, and like the current, the voltage, and how the domestic electricity works. Different things you can learn for this current electricity part. And the electronics, yeah, that's obvious. We're gonna daily use in the electronic things. And for the electronics, we're gonna learn about how the electronic components are working, and there are different types of electronic components that we need to specifically learn for the A level. And a lot of electronic concepts are going to learn with this ninth unit, the electronics. And 10th one going to be the mechanical properties of matter. And that is going to be like you can see here, if I just grab this piece of string here, I could just stretch it, and once I release the force, it's going to come back. So it's going to be similar to a rubber band, or maybe a wool band, or maybe any other elastic things. And we're going to learn about how those things are getting stretched, what are the forces that have been building up, and something called surface tension. I think you may have heard about, like for the O levels, there are these kinds of insects who can just walk on the water or maybe any fluid surface without being sinking. And those things, how these kinds of things are working, gonna learn for these mechanical properties of matter, and that's the 10th unit. And the last unit, the 11th unit, going to be the matter and radiation, and that part we're gonna learn about different types of radiation. I think you may have heard about gamma rays, the X-rays, different types of radiations, and how the nuclear power plants work, and different things about the nuclear energy, and different reactions are the nuclear fusion reactions, how we can use that one to produce heat, and sort of different interesting concepts going to be learned for the last part, the matter and radiation. And you may have seen here under this 11 unit, we can like dive deep in different concepts, but all the things are related to the day-to-day scenarios, right? Okay, so besides that one, you can see the number of periods that have been allocated for each and every part. So period is going to be the usual period that we do in the schools. Each period going to be 40 minutes. So for the very first unit, we just need to spend 30 periods. So which means 30 to 40 minutes into 30. So this much of time we need to allocate to finish up the first unit, right? And going through, you can see the largest one, and that is going to the mechanics, having 110 periods, and the least one going to be the gravitational field, having 20 periods, right? So we are now at the very first unit, the measurements, and we have been finished up the very first part, the units and dimensions, right? So don't worry about it too much. I'll later on teach you that part in case, or maybe you can catch it up very soon. So today we're going to start about the next part of that measurements, and that is called the measuring instruments, right? Before that one, let me give you a very quick recap of what we were learning for the very first part. Very quick recap. I told you uh, in the measurements we're gonna learn about the different measuring techniques. So what are the physical parameters that we need to measure, right? And in that case, uh, there are some physical parameters that we can measure up directly. For an example, let's say you go to a shop, and ask from the Mudalali to give something, maybe sugar, right? You need 50 grams, 500 grams of sugar. So you just request, okay, Mudalali, I need 500 grams of sugar. So will he be saying, okay, just wait, Puta, I just need to do some math, and he's just doing some calculation and measuring up it, or he just grabs something, maybe a shopping bag, place it on the balance and pour the things. That's how it works, right? Yes. So in that case, you can see that the mass is kind of a thing that we can measure directly, right? And that those kinds of parameters, the parameters that we can measure directly are called something fundamental, fundamental physical parameters, physical quantities. So fundamental means you can see the idea. Fundamental is something basic, right? So fundamental physical quantity is going to be the physical quantity that we can measure directly. And one was this mass. What are the other things that we can measure directly? Yes, exactly. So if you need to measure the length of this, maybe the table, you can grab a meter ruler. Let's say this is to be a meter ruler. You can just, this is not a meter ruler, but let's suppose that one. So you can just place it like this, and you can measure up the length, right? Easily. I mean, we can have a measuring tape. Last day I had brought one. So yeah, length is going to be a fundamental physical quantity. What else that you can measure directly? Okay, something with the volume, but we can't say that one directly, right? You can just see this one and say the capacity of this to be 500 liters. You can say it like that, right? What else? Let's say one of your friends meets in the maybe in the bus or maybe in the school and ask like, let's say, machan time meka kiyada, right? So you just say, wait, machan, I just need to do a math. And 23, like you don't need to do, right? You can just see the watch and tell the time. Now it's around now 9:36, right? So which means the time, something we can measure directly, and that is also going to be a fundamental physical quantity. What else? About this one, I just saw the thermometer here in the lab and said that it is 24 degrees Celsius, which means the temperature also can be measured directly, right? So that is something called thermodynamic temperature or just temperature. And there are three more, right? Uh, you can see this one I have given on the page 2 on the table, and there's a chart. So something called electric current is there, and the amount of substance, and something called luminous intensity, right? Electric current is the amount of current flow through these wires, right? You know that there's electric current that is flowing through, that's why the lights are being lighted up, and that we are measuring with this electric current. The amount of substance means especially dealing with the chemistry, or maybe if you need to say something in the very atomic scale, I think you have learned about some unit called moles for the O-level chemistry, and that's going to be the unit of this one. And amount of substance means something measuring in the molecular or atomic scale. And the seventh one going to be the luminous intensity. And luminous intensity means how much of bright a certain environment is. You can see here right now it's kind of very much bright, but I can just turn on this light, and even this one, it's going to be kind of darker, right? So for the luminous intensity, we are measuring up the intensity of the light, and that part is there. Different sensors are there, especially in these cameras. And maybe let's say you are taking a selfie or maybe a photo, and these phones also have some color sensors and also light sensors, right? So that, yes, yeah, that also works with something about the light. And I think you have seen, like, once you're gonna capture some photo, they're gonna like adjust the light a little bit to make your face brighter, right? And that all being done with this measuring of the luminous intensity, how much the light is there. And there are different units. So for the length measurement, we can use the centimeters, meters, kilometers. I know you told me like it's around 4 kilometers from here to your home. So which means there are different units, and not just this one. We have very obsolete units like inches and feet, right? Different units are there. So after a while, after that, I think you have learned for the history that what do you call that? There are some revolutions happens. An industrial revolution. After the industrial revolution, the worldwide they need to have a standard unit for measuring up these things, and they have built up something called SI unit, Standard International Unit. It's the abbreviation for Standard International SI. And there are different SI units for these measuring up these 7 fundamental physical quantities. And for the length measurement, I told you earlier we have kilometers, meters, inches, feet, whatever. So the SI unit is going to be meters. And for the mass, we have kilograms, grams, maybe milligrams, or the obsolete ones, the ounce, pounds, right? From all, we're going to use kilograms as the SI unit. For the time, we have seconds, minutes, hours, but the usual going to be the seconds. And the temperature, we have the, I think I mentioned earlier, it's degrees Celsius, or you can say something called degrees Fahrenheit, or there's another one called Kelvin. So we're going to use the Kelvin, K, the capital K, to measure up the temperature. And the electric current, we're going to use ampere, this capital A, ampere, and this is Kelvin. And amount of substance going to be mole, and that's just mole. And luminous intensity is going to be measured in a very different something called CD, stands for candela. Candela, right? So those things also given in the same table that I have given you earlier in the page 2, the SI units and the symbol given, right? And these are called the fundamental physical quantities. Out of those fundamental physical quantities, we can build up some other quantities. For an example, if you just consider about uh, the speed that we have considered earlier, speed. So we found the speed to be the distance divided by the time. So you can see here distance is going to be a length measurement. You told me it's around 4 kilometers, so it's going to be a length measurement. So distance is going to be a fundamental physical quantity. Time, yeah, it's obvious, it's going to be a fundamental physical quantity. From these two, we are just doing a math here, which is the division, and finding out a parameter called the speed. So speed, we can't measure it directly. You can't just see a car. Well, you can say that, okay, it's going very faster or maybe very slower. But you can give a numerical value, right? In order to give a numerical value, we need to know these kinds of equation, and we need to do some math here. And finally, we can calculate the speed, which is involving two fundamental physical quantities. And the speed then is named as a derived physical quantity. So the idea is that derived means something getting built up, deriving from these fundamental physical quantity. We can just add them, or we can subtract, or we can do any kind of math between those fundamental physical quantities, and you can get a derived physical quantity. Likewise, let's say somebody asks, okay, what's the area of this table? You can't just say 5 square meters, right? You can just say like that. Instead, you need to do the measurements to be the length measurement and the breadth. You know, you can say the area to be length into breadth. So again, area is going to be length, into breadth. So length is going to be a length measurement, a fundamental physical quantity. Breadth is again a length and again a fundamental physical quantity, and you are doing multiplication between them, which the area is going to be a derived physical quantity, right? Likewise, there are dozens of derived physical quantities that we can learn. Derived means something getting derived or building up from the seven fundamental physical quantities. That's the overall idea. So that was like the basic approach, and we learned something called dimensions. And I'm not going to go through that part today. Last day we have finished that part, right? So I'm giving you a basic introduction to this physics and what we are basically going to learn throughout these 2.5 years, right? It's going to be like 2 years and around 4 or 6 months, depending on which month you're gonna have the exams. Either way, it's 2027. So throughout this 2.5 years, we're gonna learn about these concepts, right? Okay. So today we're gonna learn about the measurements and measuring instruments. Okay. So let's write a topic. I think you don't need to leave the space to write the beginning part, right? You can write the topic to be measurements and a subtopic to be measuring instruments. So you might be wondering, aren't there any textbook for the A levels, right? Unlike the O levels. Well, no. Uh, you don't get any textbooks even in the school. So there are some. There are two books that maybe you can purchase if you need. Something called resource book, which gives a guidance for all these parts, like for the combined maths and for the physics and the IT. Something called resource book, and a syllabus is there. You can basically download it online as well, right? So that just give a like overall idea of the concepts that we need to learn, but not like the O levels. We have some like special notes and some example questions. Likewise, you can't see any book for the A levels, so it's kind of DIY stuff. Right? You need to do it yourself. And from these classes and in this course, the teachers are going to guide you throughout the course and giving some notes and some example questions. Within this class, we're gonna give these kinds of interesting tudes, and there are some practicals involved, so you're gonna do the practicals within the class. In the school, so you can do the practicals. So there are in the beginning class I have mentioned there are 41 practicals are there, and out of those 41 practicals, we are trying our best to do around 32 practicals within the class. Rest of the practicals, there are some special apparatus that only given for the school labs, so that's why it's kind of recommended to go to schools as well. If you are going, but you can apply private. What do you prefer, like going to schools or maybe apply private? Okay, so you're gonna go to the same school. You can try to apply for the central. This house. Okay, okay. We hope you could just go to the central too, right? Or else you can have the like there are the A levels, right, in these schools. Okay, great. Uh, all right. So yeah, that's about the practicals, and there are practical questions have been asked as well. Yeah. Okay. Okay. So we're gonna learn today from the onwards the measuring instrument, right? And there are dozens of measuring instruments that are there, like the temperature and the length, the time, and everything, right? But out of that, in this part, we are just going to learn about four measuring instruments, and that have been using the school labs, and also only for using in length measuring applications, right? We are not going to consider about the mass measuring or the time and the other measuring things, only for the length measurements. And the next thing is I'm not going to give you some like very lengthy notes. I'm gonna give some bunch of notes with some points so that the book is going to be very interesting and you can go through the note very quickly, right? Okay, so let's write a very little note for this part. We write. there are different types of measuring instruments. There are different types of measuring instruments in the school labs to measure different physical parameters. To measure different physical parameters. Okay. Out of them, in the A-level syllabus, you can continue the same paragraph, or maybe you can write a new point, right? In the A-level syllabus, we are going to consider 5 measuring instruments used in measuring the length. Okay, so we write one after the other. First one going to be the meter ruler. Meter ruler. Second one going to be something called Vernier caliper. And the third one going to be micrometer, screw gauge, screw gauge. And the fourth one going to be something called spirometer, spirometer. And the fifth one is going to be traveling microscope. Right. So these are the 5 measuring instruments, and they are only involving in length measurements, right? We have the other instruments like the triple beam balance, and I think you have heard it for the O levels, right? There's something called triple beam balance. You can just slide the masses and measure the mass, or something called chemical balance, like this one. Like you just have the traditional balance like this, right? Or if the digital balances are there, all they are using for the length mass measurements. And there are different types of watches. Like I have seen the stopwatch, right? Click click, you can just set and reset, and those are for the time measurements. And yeah, there are like thermometers are the different types of thermometers. The mercury glass thermometer, the digital thermometers are there. Those are involving it's under temperature measurements, right? And I think you have learned about the for the current we have the ammeters and voltmeters, which we can learn in a future lesson, the current electricity. But currently we are focused with the length measuring instruments, right? Okay, so we write a subtopic meter ruler. That's kind of a traditional measuring instrument, and it's just not being used for measuring the stuff. You may have punished with that too, right? Sometimes the teachers used to use the same meter rule to punish the students. So anyhow, we are using that one to measure the length. I think you have seen kind of a yellow color stick for the meter ruler. I'm not going to. I think in the piece of sheet that I have provided, I haven't given you the diagram as well, because you have seen that one already many times. Okay, so let's see how it is being calibrated. So it's going to be 0, and there are going to be some marks here. It's going to be 1 centimeter. So which means we have 1 centimeter here, and that is being divided to 10 segments. And this is pretty much the same as the ruler that you have. But in this case, this is going to be 100 centimeters, and that is going to be exactly 1 meter in length. So I'm going to draw it like this way. So we have the 1 centimeter mark. This is 1, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is 2, and so on. Right? Even though I have just drawn it to be very large, the actual size is going to be very much smaller for 1 centimeter. You can see it from the ruler. That do you have a ruler with you? Okay. Yeah. Okay. So the actual 1 centimeter is going to be very small, but in this case, I have just zoomed it and have drawn it. I'm gonna draw it like this. Alright, so this is not the meter that is being broken in half, but I have just drawn it kind of short in the distance because I can't draw the entire, the 100 segments, right? So I have like showing that I have just broken in the middle, like, splitted in the middle and have drawn it. So anyhow, this is being calibrated in centimeters, and for a standard meter ruler we have 100 segments, and between the 1 centimeter gap we have like small calibrations to be divided by 10. So each of segment is going to be then how much? Yeah, it's going to be 1 millimeter. This little gap here is going to be 1 millimeter, which you can find out by 1 centimeter has been divided to 10 segments. So each of the segment is going to be 1 millimeter. Alright, so that's how the meter ruler is. We'll just sketch it. Okay, great. So we're writing point wise the properties that we could see here. The first point, the standard meter ruler is 100 centimeters. Within brackets you can write 1000 millimeters in length. Second point, the distance between two consecutive calibrations. The distance, second one, the distance between two consecutive calibrations. Distance between two consecutive calibrations. How much? Yeah, two consecutive calibrations and going to be 1 millimeter. Is 1 millimeter. You can write the third point. Therefore, do you know how to write the therefore with 3 dots? Okay. Therefore, the minimum measurement the minimum measurement, and we're gonna give a single term for that one. For the minimum measurement, we say something called least count. So you can write within brackets least count is 1 millimeter. Why we say so? Yes, exactly. So if you have the ruler that you have, what's the smallest measurement that you can have? It's just this gap, right? Just 1 millimeter. So in a meter ruler, we say the least count is to be 1 millimeter. That's the minimum measurement that we can measure from this gadget. Right? Okay. The next and the last point. When taking a measurement, when taking a measurement, it should round off to the nearest millimeter. It should round off to the nearest millimeter. You can continue the same point. Thus, there will be a maximum error. Thus, there will be a maximum error of 1 millimeter. Alright, so it's like this. Let's say we are using this meter ruler to measure a certain piece of wood or whatever, right? Let's say it is going up to here. Maybe we'll see it from. Can I borrow your ruler for a second? Okay, thank you. Okay, you can see the breadth of this one too. That's it. You can just have it and see the breadth measurement. How much exactly it is. Okay, so which means kind of a scenario like this, right? You can see the measurement that you had was kind of in the middle of these two calibrations, right? So one can say, so it is like 1, 1.1, 1.2, 1.3. Right? You can say it is 1.3. So it's 1.3 centimeters. Maybe one of your friend can say, okay, Machan, it has been past the 1.3 because the 3 has been passed. So kind of in the middle. So he can maybe say it's 1.4 centimeters. You can't say it to be 1.35 because it is in the very middle because there's no any calibration here. So you just need to round off your value to this or maybe to this one. So if I just express this one in millimeters, all you need to do is multiply by the 10. So it is either 13 millimeters or here it is 14 millimeters. So you can see there's a difference of 1 millimeter because we have to round it off maybe to the previous millimeter or maybe to the next millimeter when we are saying that value because there are no any intermediate calibration. So let's say you have like you are saying it to be 13 millimeters and the other friend is saying 14. So there's a difference or we can say there's an error of 1 millimeter because your reading could be errors with 1 millimeter because we just need to round off it to the nearest millimeter. Got it? Okay, great. So which means using this meter ruler, there could be an error of 1 millimeter. Right? We need to deal with these errors because measuring the thickness of that wooden piece is going to be not much. But let's say we are like building up something for the International Space Station. Do you know that there's something called International Space Station, the ISS, that's just orbiting around the Earth, and which is on the outer space, right? But the things have been building on the Earth and taking them by the rockets and fitting into the ISS, right? It's going to be decommissioning very soon, but it is like we have like several tons of parts has been merged to that one, and in that case, let's say a tiny millimeter error could result in a huge catastrophic failure, because let's say you are manufacturing something on the earth, bring it to there, but let's say it's not fitting to that, right? So in that case, we need to bring it back to the earth, because we can't just grind the things and maybe we can just sand the things there, right? We just need to return it back to the earth, which costs several millions of dollars. So in that case, the precision is very much important. So we need to like have this error to be minimum. If you are using a meter ruler, there's an error of 1 millimeter, right? That doesn't affect for these things, but let's say we are manufacturing some machineries, let's say a vehicle engine. So in that case, we need to have a huge precision to make the things to be very accurate and all, right? So yeah, in the meter ruler, we have the error to be this much, and that is getting equal to the least count too. You can see the least count, the minimum measurement that we can have is 1 millimeter, and the error also going to be 1 millimeter. Okay, that's about the meter ruler, and let's discuss about this error it can have, right? Not just for this meter ruler, for whatever the measuring instrument. So we'll write a subtopic. Uh, Error in a measurement. Error in a measurement. Okay, we write underneath a little note. Uh, there's an error encounter. There's an error encounter when using any measuring instrument. When using any measuring instrument. For an example, when taking a measurement from a meter ruler. When taking a measurement from the meter ruler, there's a maximum error of 1 millimeter. 1 millimeter. Okay, next point you can write. Even though the maximum error is relevant to the measuring instrument, the impact of the error in the final measurement or final result, in the final result are expressed in two ways. So when it comes to this one, the meter ruler, we have this maximum error of 1 millimeter. But when you use different measuring instruments, we have different maximum errors. So instead of saying the maximum error that is kind of specific to the measuring instrument, we can use a different calculation to show the final impact of this error. Right? Let's say you are using this one to measure the length of this one, or maybe like using some other techniques. You're gonna have, let's say, okay, let's say we are finding out the area of this thing, area of the cross section of this thing, right? So in that case, we need to measure the length and the breadth. So we're gonna use the same meter ruler here, going to be the length and the breadth. And when measuring the length, we are having an error of 1 millimeter. Could be having error of 1 millimeter. And when measuring the breadth, also we need to like encounter 1 millimeter error. So we don't know what's the impact that error for the area, because area is length into breadth, L into B. When measuring the length also we are having an error. We are having, for the breadth also we are having an error. But multiplying them, we don't know what's the error it creates for the area. Right? What sort of error is there for the area measurement? So in that case, instead of saying the maximum error that could have, we can express the error in two meaningful ways. And the first one going to be the something called fractional error. And the second one going to be the percentage error. So we write them one after the other. You can write it down. First one, the fractional error. Second one is the percentage error. Fractional error and the percentage error. Okay. So we write how we can measure up the fractional error. There's an equation for this one. Fractional error is going to be equal to the maximum error divided by the standard measurement. This is how we find the fractional error, right? And let's consider about the meter ruler. That's the very first measuring device that you have learned. So what's the maximum error it could have? 1 millimeter, which is again going to be equal to its the shortest gap. What's the term that we have used there? कदा අපි එකට use කරේ? Yeah, the minimum distance that you can measure. Least count. Okay, so you have seen here the minimum distance that we can measure, or to be the least count for a meter ruler, that is 1 millimeter. Also we have considered, due to this one, we need to round it off to the nearest millimeter. That means the error it could have is also 1 millimeter, right? So you can say the fractional error to be maximum error divided by the standard measurement. Don't worry about the standard measurement part, we're going to learn about it. Regarding this maximum error, we can even write that one to be equal to the least count. Because in this meter ruler you have seen the maximum error is also 1 millimeter, and that is also getting equal to the least count, which is also the 1 millimeter. Not just for the meter ruler, for whatever the measuring instrument, when you have something called the maximum error, that is again going to be equal to its minimum value we can read, because we need to round it off to the least value. Got it? Great. So this is again getting equal to the least count divided by the standard measurement. So you might be wondering what this standard measurement is. So standard measurement is the measurement that we are obtaining. Let's say, for an example, we are going to have the length of this table. So that is going to be around 1, 2, around 3 meters, right? So the standard measurement is going to be then 3 meters. The measurement that we take is going to be the standard measurement. Earlier case, when you are taking the breadth of this one, He told me it's around 1.7. So it is going to be 1.7 centimeters. That's the measurement that you take. Alright, so this is how we can find out the fractional error. Like this. Right? And what about the percentage error? Percentage error. Percentage means something related to 100%, right? So percentage error is going to be fractional error into 100%. So how do you write the fractional error then? This one, right? Yes, exactly. So I'm going to write it here. Then percentage, okay, you can see that. Let me write it here. Percentage error equals then uh, maximum error divided by the standard measurement into 100%. Right, that's how we find that one out. Okay, let's write these two equations. This, maybe this, and afterward you can change that. Alright, so you might be wondering, aren't we doing any calculation, right? Involving a lot of theories. I'm not going to write much theories. Okay, so it's time for us to do some calculations, right? Before that, we'll write a star mark. We'll draw a star mark and write. This is a very special point, right? A measurement is suitable. A measurement is considered to be suitable. A measurement is considered to be suitable and accurate when the percentage error is lesser than 1%. Is lesser than 1%. Right? So whenever you need to take a reading, and that's supposed to be taken to be very much accurate, when this percentage error should be lesser than 1%, right? We'll see about that one with a certain example. We write example 1, a question. Example 1. Find the percentage error continue that same question. Find the percentage error when using the meter ruler to obtain a length of 25 centimeters. Length of 25 centimeters and check whether the meter ruler is suitable. Whether the meter ruler is suitable in taking this measurement. Alright, so give it a try. What's going to be the standard measurement then? 25. Okay, what could be the maximum error? Yeah, so we are using the meter ruler, so it's going to be 1 millimeter, which is again getting equal to the least count. Okay, give it a try. Okay. So you might have missed one, and that is this is 1 millimeter, fine. So 25 is given in centimeters. So which doesn't cancel off the unit. So you need to do that one. We need to convert this 25 centimeters again to millimeters, which is going to be 250 millimeters, and into 100%, which cancels off just one, and that is going to be 10 divided by 25. That is 0.4%. Okay, great. Otherwise, we will end up with 2 units, and that not cancel off, right? So in the numerator and denominator, we should have the same unit. Alright, now tell me, is this one suitable in taking the measurement? Why? No. So earlier we have considered that putting a star mark, a certain measuring instrument is suitable when it creates a percentage error lesser than 1%. So you can write 0.4% is lesser than 1%, right? Therefore, this measurement is the measuring the meter ruler is suitable for taking this measurement. You can write like that. You can write this, and therefore the meter ruler is suitable to take this measurement. Okay, let's use the example 2. Right? Example 2, right? If the same meter ruler above being used to find the diameter of a pen. Let's say this pen. What can you say about the diameter of that? Do you know how to find the diameter? Just this part, right? Okay. Get a rough value. Okay. 1.4. Okay. So 1.4 means we write in millimeters. It's 14, right? 14 millimeters. Okay. Uh, Obtain the diameter of a pen, and it was 14 millimeters. Find the suitability. Find the suitability of meter ruler of the meter ruler in taking this measurement. Okay, give it a try. So you can shorten this one in if you need, right? Percentage error PE, maximum error to be the max error. Likewise, you can write standard measurement SM in case, right? Yeah, 7.1%. Now tell me, is this one suitable? No. So it's the same meter ruler, but now the percentage error is around 7.1, which is greater than 1%. You can write here, okay, like this, and the meter ruler is not suitable in taking this measurement, right? The meter ruler is not suitable in taking this measurement. All right. Now let's think about, okay. So if you are using the meter ruler, then what is the standard measurement or the measurement that we supposed to have the percentage error to be 1%? Now we know that, okay, we need to have the percentage error that should be lesser than 1% to make that measuring instrument to be accurate or being suitable for that. So let's say if we are using the meter ruler, the percentage error has to be 1%, and the maximum error it will be having will be 1 meter. Let's say the standard measurement will be the SM into 100%. You can see here I can cross multiply this one to the other side, and SM, the standard measurement, is going to be, this is percent cancel of 1 millimeter into 100, going to be 100 millimeters, which is going to be around 10 centimeters. So in order to use this meter ruler, we need to at least measure 10 centimeters to make the to make the percentage error to be equal or lesser than 1%, right? At least we need to measure 10 centimeters. Otherwise, the meter ruler is not being suitable. But we are having an issue in here. We can't measure 10 centimeters because it is already around 1.4 centimeters. So what we can do when you are using the meter ruler? We need to measure at least 10 centimeters. So one thing that you can do here is Instead of measuring just one, you can stack few identical uh, pens like this and maybe measure a value that is greater than 10 and divide by the number of pens. And will not going to work very much because you can't just stack them properly. And see here there will be some gaps, right, in the middle, so which is not going to work. So using a meter ruler, it's good to have the measurement that is greater than 10 centimeters. For the measurements less than 10 centimeters, the meter ruler is not good because we're gonna encounter higher error there. Somehow we should try our best to reduce the error that we can encounter. So which means we can't use the meter ruler when you are measuring smaller lengths, lesser than 10 centimeters. Got it? Great. So if you need to like have a lesser percentage error, you need to make it to be lesser, let's say. In order to make it lesser, we can do two things. One will be we could reduce the maximum error. Right? We can reduce the numerator here. That will also reduce the percentage error. Or else we can keep the maximum error as it is and we can increase the standard measurement. We can increase the denominator and that reduces the value here. You know, like I can take some counter examples. Let's say I can have 1 over 10, which is going to be 0.1. I can reduce this one even more by dividing 1 over 100. I have increased the numerator by 10 times so that the value is going to be very much lesser. That I could do, and that is the same thing that we have done earlier. When using the meter ruler, earlier case we have measured 25 centimeters, but in the second case we have measured just 25 centimeters means 250 millimeters. The second case we have just measured around 14 millimeters. So here you have a higher denominator, so it reduces the percentage error to around 0.4%. But in the next case, we couldn't do because we can't play with the standard measurement that got reduced to 14%, 14 millimeters, and this has been increased to 7.1%. Right? Reducing the denominator will increase the value here. Increasing the denominator will reduces the value in this case. So we could either have a higher standard measurement, but the issue here is if you need to measure the diameter of this pen, we can't measure something else, right? Having a higher standard measurement is going to be exactly should be this value, whatever it is, right? Which means you can't just play with the standard measurement. That is the measurement that we're supposed to measure. So without changing this part, and there's a method to reduce the percentage error. What is that? Reducing the numerator here. And how we can reduce is the maximum error there. And if you can remember, earlier case we have considered the maximum error is getting equal to what? The least count. The least count. You can write LC or least count. And least count is something endemic to the measuring instrument. We can't change the least count of a meter ruler. Why? Because it is been already calibrated with 1 millimeter gap. You can have another calibration in the middle like this, which hardly distinguished by the naked eye, because even you are like reading this 1 millimeter gap to be very hard, right? A millimeter කියවන්නේ තැනම ගේමක් දීලා, right? So how can we measure like a value in the middle like 0.5? Right? It's going to be very hardly distinguishable by the normal eye. So in that case you need to have a magnification glass as well. So you can't just divide this one again even further, which means you can't change the least count of this meter ruler. Instead, we need to switch to a different measuring instrument. And that is why we have, guys, the other ones. The second one, the vernier caliper and the other measuring instrument. So from all the measuring instruments, what we are trying to do is we are going to reduce the percentage error, because you have seen here for higher length measurements it is okay, the meter rule is fine. But when measuring some smaller values, you're gonna have a higher percentage error. We should maintain the percentage error to be always less than 1% to that measurement to be accurate. To have the percentage error to be less than 1%, one thing is you can increase the standard measurement, which you can't do when taking a measurement. But you could reduce the maximum error. Reducing the maximum error means you should reduce the least count. And the least count is endemic to a certain measuring instrument. For a meter roller, it is 1 millimeter. And that is why we need to switch to a different measuring instrument to have some smaller readings. Okay, good. So that's the overall idea. We write underneath. Therefore, you can write 3 dots. Therefore, in order to take smaller measurements, and the percentage error to be maintained less than 1%, percentage error to be maintained less than 1%, we need to switch to other measuring instruments which are having lesser least count. Lesser least count. Do you get the idea why we need to switch to different measuring instruments? Great. Alright, so we'll write the second one, the vernier caliper. Vernier caliper. Alright, so have you done what you have done for the third selection for the O-levels? IT. Okay, great. So if you have done something called designing and technology DT, you can see this vernier caliper for the O-levels, but totally fine. Right? Have you seen this one, vernier caliper? Okay, where? Ah, okay. Great. So he has done A-levels from the science stream. Okay, great, great. That's a good start. You have like went through the brother's book, so you have kind of rough idea. All right, great. So before we discuss about the vernier caliper, we need to learn about what is this vernier thing, right? So we'll write like this. We first write vernier caliper, right? This is used to measure smaller readings. This is used to measure smaller length measurements. Smaller length measurements with a higher accuracy. Okay. Vernier caliper uses vernier principle. You can write in the next point or you can write in the same paragraph. Vernier caliper uses vernier principle. Let's discuss it first. Okay, then we'll write a subtopic under the vernier caliper, right? Vernier principle. Alright, so let's learn about it. It is like this. So we're gonna have the usual meter ruler, or that is calibrated with 1 millimeter gap. 1, 2, 3, 4, and this is 5, 6, 7, 8, 9, this is 10. That's going to be 10 millimeters or 1 centimeter, right? And so on. I'm going to write 1 centimeter, or yeah, you can just put 10 millimeters. It's basically 1 centimeter. 1, 2, 3, 4. Again 5, 6, 7, 8, 9. This is 10. So it's going to be 2 centimeters or 20 millimeters. Right. Even though I have drawn it very much larger, you have seen that 1 centimeter is going to be very small gap. But for the sake of understanding, I have just drawn it to be extended and kind of zoomed. Right. Alright. So what we're gonna do here is we are going to have the vernier part. Oh, this is called the main scale. Let me write in the same color. This is the main scale. And we're gonna have something called the vernier scale. So usually what we can have will be, we can take 9 segments of the main scale, which means 9 millimeters, from here all the way up to the 9 millimeter, and divide it equally to 10 segments, which means here 0 and here it is 10. So I have chosen 9 millimeters and divided to 10 segments, which means there has to be equal amount of gaps here. 1, 2, 3. All I could just do is kind of divide in the middle. Okay, it's going to be 1, 2, 3, 4, 2, okay, 5, 6, 7, 8, 9, and 10. Alright, so I have chosen 9 millimeters and divided to 10 segments. Can you tell me what's the gap between two consecutive segments in the main scale? Yeah, that is 1 millimeter. Well, we can obtain that one by 10 millimeter here has been divided to 10 segments. So each of this will be 1 millimeter. Can you tell me what's the gap of here? We can see here 9 millimeters has been divided to 10 segments. Here 10 millimeters divided to 10 segments, so it is 1 millimeter. Then here 9 millimeters has divided to 10 segments, so each part going to be 9 over 10, that is 0.9. Got it? Okay. So this is called the main scale. This is called the vernier scale. Okay. Let's first draw this one. So when drawing it, try your best to have the same gap. And notice here, we are not tallying with any main scale with the vernier scale. You can see here, this is the main scale 1, this is the vernier scale 1, and we have a small gap here. The only calibration that is getting tallied will be the 9 and 10 here. In the middle, you can't get tally with any of the vernier part with the main scale part. Okay. Okay. Great. Now we write some properties of this one. We write in point wise. The first point. main scale is calibrated in millimeters. Main scale is calibrated in millimeters. Okay, next point, right? Vernier scale is made. Vernier scale is made by dividing 9 millimeters in the main scale to 10 equal segments. To 10 equal segments. Right? You can write, therefore, length of a vernier segment. Length of a vernier segment. Length of a vernier segment equals, I can find it that one out. Well, 9 millimeters, yeah, 9 millimeters from the main scale has been divided to 10. It's going to be 0.9 millimeters. Okay. So underneath we'll write in the next point. For any vernier scale, and put a comma, we're going to write with an equation, least count. So you're supposed to know how we can find out the least count here. If it is just this one, the main scale, the least count is going to be 1 millimeter. But now we have a vernier part as well. Let's see how we can find out the least count. So least count is going to be equal to length of a segment in main scale and should subtract by length of a segment in vernier scale. This is how we can find out the least count. You will get to know why we are having the least count to be like that and how we can encounter that, right? We'll first write the equation. Alright, for this particular example, we could find out the least count. How? Length of a segment in the main scale to be 1 millimeters. Subtract by length of a segment in the vernier scale, here it is 0.9 millimeters. What could be the value? Yeah, it's 0.1 millimeters. So see how sensitive this one is. When using just this main scale, we can have a least count. The least value we can have will be just 1 millimeter. Even though the 1 millimeter, it is very hard to distinguish from our eyes, right? You can see the 1 millimeter mark in your ruler, right? Very small value. So using this Vernier principle, we can go up to the least count of 0.1, even 1/10 of that tiny gap, right? And that is how we can find the least count of this. Later on, we'll figure it out how we can embed this Vernier principle to a measuring device, and that is the Vernier caliper, right? And before that, we'll learn about the Vernier principle even much, right? Okay, so let's write this, and we can calculate the least count. Okay, great. Afterward, we write Did you catch this one? Okay, great. Afterward we'll write uh, from this there's a gap of between there's a gap between main scale, you can write M1, that's the main scale one, and Vernier scale 1, V1, which I am implying here, the main scale one going to be this one, this is the one, right? And here, the Vernier scale one going to be this. What will be the gap between? You can see there's a tiny gap between these two calibrations, a little gap here. You can see for your own diagram, right? There's a little gap here. So what could be the distance between the two gaps? Yeah, it is going to be 0.1 millimeters. What can you say about the gap between the main scale 2, M2, and Vernier scale 2? This 2 and this 2. Yeah, it doubles. Great. Why? Because now we have here like 0.9 times 2 and here we have 2. We subtract that and you're gonna have 0.2 millimeter gap. Vice versa, we can write M3 and V3. You can have 3 and 3. Yeah, it's going to be 0.3 millimeters. And you can write this one even more. And you can have M10 and V10. This is the main scale 10. This is the Vernier scale 10. And you're going to have a gap of 1 millimeter. So you can go with 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and finally 1 millimeter. Got it? Great. So that is going to be 1 millimeter. Okay, let's write that one. Okay, now tell me, if I just slide this Vernier scale a little bit to that side, right? And let's say it happens like this, right? We have the entire thing to be, let's suppose that the entire thing has been slided. I just draw it like this way, maybe this. Let's say like this. You can see here the one in the Vernier scale and the one in the main scale got been like tallied like this, right? You can say it is to be coincide. I think you familiar with that term, right? Coinciding for the O levels, maybe for the congruency and those things. You can just fold it and the sides gonna coincide one over another. So the same thing happened in here. So let's say I have just slided this Vernier scale a little bit to the right side, and let's suppose that the one and the one is got coincide like this. So tell me how far that you have slided this one there. Exactly, very good. So earlier we had a gap of 0.1 between the main scale 1 and the vernier scale 1. If those get coinciding, that means we have slided the vernier scale by a little distance of 0.1 millimeters, right? Let's say, for an example, like you have just slide in this one, and let's say maybe the 5 and the 5 got coincide here. That means you have slided 0.5 times. Let's say somehow you just slide it and the 10 and 10 got coincide. How far you have slided that one? 1 millimeter. Got the idea? Great. Which means we can slide the vernier scale along the main scale, and the value that is coinciding going to match with the distance that you have slided that one, right? Okay, that's it, right? We write like this, the new point. When the vernier scale, when the vernier scale is slided along the main scale, a segment, a segment in the vernier scale, you can write in short like V scale, right? If you need. A segment in the vernier scale gets collinear, or within brackets we can write come to the same line with the main scale, with a main scale segment, sorry, with a main scale segment. This is known as coinciding. This is known as coinciding. You can write therefore, it's a new line you can write, therefore a reading can be taken as follows. A reading can be taken as follows. Right. So let's say it is like this. So the earlier case the vernier 0 and the main scale 0 was coinciding 0 0. But now let's say we are going to measure a little piece of this maybe. We'll go here. This is something that we are going to measure. Right. What could be the value? Something passing the 3, right? We have pretty sure that the 3 millimeter has been passed. So we can take the reading to be the value in the main scale. Here it is 3 millimeters for sure. Plus there's an additional part that we can't measure from the main scale because we have no calibration in between, and that is why we need to use the vernier scale. So to make this piece to be fitting in, earlier case the 0 and 0 of the main scale and the vernier scale were coinciding. To fit this one in, we should slide the vernier scale exactly up to here, like that. Earlier the 0 0 was coinciding. In order to make this one fit, we need to slide the vernier scale a little bit until it properly fits with the 0 0 from here, and the next part to be like this, right? So let's say it is 1 2 3 4 and 5, and here the 6, let's say 7 8 9 and 10. right? You can see here, okay, so tell me which segment of the vernier scale been coinciding with the main scale? This is 1, 2, 3, 4, 5, 6. Sixth one is been coinciding, but it is not been coinciding with the sixth of the main scale, right? It is now been coinciding with around the ninth of the main scale. But you don't need to take it from the main scale. You're supposed to take it exactly from the vernier scale, right? So we should add now 3 is surely passed. There's some additional value here, and that you should take it from the vernier scale. So how do you do that? We know each of this segment is going to be 0.9, and the least count that we can measure is going to be 0.1 in here. So if like 1 and 1 being coinciding, it's 0.1. 2 and 2, if the 2 is coinciding, it's 0.2. 3 is coinciding, 0.3, 4, 0.4, and 5, 0.5, and 6 is going to be 0.6, which means you need to have the least count to be multiplying with the coinciding vernier segment. Is that so? Because least count going to be 0.1, and if the 1 is being coinciding, it is 0.1. 2 is going to be 0.1 into 2. 3, 0.1 into 3. Because we know if it is just being slided a little bit like 1 and 1 coinciding, it is slided by 0.1. 2 and 2 coinciding 0.2. 3 and 3 is 0.3 likewise. Now it's the sixth one that is coinciding, not with the sixth of this one, but a certain value from the main scale, which means it has been slided 0.1 times 6. Got it? Great. So let's take the reading here. 3 millimeters plus. What's the least count? Yeah, it was 0.1 here. Very good. Now the coinciding segment going to be the sixth one. So it is 6. Alright, so we could write it is 3 millimeters plus 0.6 millimeters. Yeah, it is 0.3.6 millimeters. Just like that, okay. So maybe write it at the very bottom. It is 3.6 millimeters. Without this vernier part, we will never able to calculate the middle value, right? Either we should be to take it to be 3 millimeters, or we should take it to be 4 millimeters, right? So now we have reduced the least count to be 0.1, so that we can measure up even the intermediate value here. You can say it's kind of like 3.5 has been passed somehow, but even though I have drawn this one to be very extended or kind of zoomed, the actual case, you can see the 3 millimeters is going to be very more small, right? Okay, so that is how we can find the value, and it is going to be a equation that you can use to take a reading. Are you okay with this one? Crystal clear? Great. Okay, great. So I think you're supposed to draw this one too. So make sure you're marking the coinciding segment with an arrow here. Alright? Great. So we're gonna have maybe a quick 5-minute break, and you can just go around, maybe have some fresh air. Right. So I have drawn again the same diagram that we have drawn earlier for the vernier and the linear and the main scale. And you saw here, in order to find the least count, the equation that we have used here is finding the segment in the main scale and finding a segment in the vernier scale, and we did the subtraction. But there's another method that you can find that one out. It is like this. You can use another equation to find the least count of this one. Least count. What if I take it like this way? Length of a main scale segment. Scale segment, which is going to be 1 millimeters here, right? And if I divide by the number of vernier divisions, think about it. How many divisions are there? Vernier divisions? 10 divisions. So I just divide by 10, and this way also I am getting that 0.1 millimeters, right? Which means you can find the least count very easily rather than the other equation, which you need to, like in that case, you need to find the length of a segment in the main scale, which can be found out very easily. But length of a segment in the vernier scale, you just count out, okay, how many segments have been taken here and divide by the number of vernier divisions and do the subtraction. Instead, you can use this equation very easily to find the least count. This is the next equation that we can use in whatever the vernier scale it is, right? In this one, it is kind of seems to be okay with the other application, the other equation too. But just come to the page 10 on the tute. Page 10 and question 2. It says find the least count of the following vernier scales. First one seems to be very easy, but seeing with the second, third and fourth one, they're gonna have a whole lot of calibrations, right? In that case, using the previous equation to find the least count is going to be kind of time consuming, but you can use this one very easily. In the scenario, you need to find the length of a segment in the main scale, which you can find out by the calibration. Let's say you have like 10 millimeters here and b equal to 10, so okay, the length of a segment will be 1 millimeter. And you can count out how many vernier segments are there, or else it will be usually given. You can see in the questions given, the starting and ending value will be given. So if it is 0 and 10, there will be 10 segments. 0 and 20, there will be 20 segments, right? Likewise, you can count out number of vernier divisions, and you can do this math and quickly find out the least count. Let's just write this one too. Okay, great. Now it's time for us to do a whole lot of questions, right? So let's come to the page 10 that we are already there. So from the page 10 onwards, you can see the questions starting from the measuring instrument. So I think you can try the very first question, not now, but going home, write the two relationship for the to calculate the least count of a vernier caliper. So we got to know the two equations. This is one, and we got to know another one earlier, right? Okay, can you write it now maybe? You can write within the cages provided on the very first question. Maybe you can go through the equation once again and without looking at the book, try your best to write it down. Okay, great. Now you can check with the equations that you have written. Just check with the equations that you have written earlier and is it okay or not? Okay, good job. Right, now let's try the next question. Find the least count of the following vernier scales. We'll try the first one and the fifth one. You can write tute 1 and part 1. one and the fifth one. Right, so the first one is going to be a piece of cake because the same way that we have done here, right? So I think using the second equation is going to be very easier than the first one. Is that the equation that you have used? Okay. So the first thing it is saying, when the Vernier scale is formed by marking the main scale in millimeters, which means the length of a segment in the main scale is going to be 1 millimeter, and dividing 9 parts of the main scale into 10 parts. So number of Vernier segments is going to be then 10. So it is 0.1 millimeter. So if you see the fifth one, this is the first one, fifth one, you'll see the least count. When the main scale is formed by marking the Vernier scale is formed by marking the main scale in millimeters, which is again 1 millimeter, and dividing 29 parts in the main scale divided to 30 parts. So there will be 30 segments, which is going to be not getting divisible much, but 0.1 divided by 3, and that is going to be 0.0333 and so on millimeters. Right? So you can see here, even we can go from 0.1 to 0.0 some millimeters, right? Very sensitive reading. So these cases, you can see the similar ones in the question, the part 2 and the second one has to be part 3, right? Sorry, my bad. So the first one is part 1, Roman number 1, Roman number 2, then after Roman number 3, not Roman number 4, sorry. So either way, you can see the second one and the third one. The 19 parts in the main scale is divided to 20 parts, and 49 parts in the main scale divided to 50 parts. And you can see those things in the question number 2, part 1. Part 1 is going to be similar to this one. Part 2, part 3 and 4. You can see it is not being taken just 9 segments. In the second part, you can see in the second question, second part, you can see 19 segment has been taken and divided to 20. The next one is going to be around 49 segments has been taken and divided to 50. So all those cases we say it is to be extended Vernier scales. The usual way going to be this one, but you can even extend that one, right? We'll try some of questions, maybe the second question part 2, give it a try. You can write tut 2 2 2, right? All right. So you got 0.05. Okay, great. So it is like this again. For length of a segment in the main scale, you can see it is calibrated in 1 millimeters, and divided by number of Vernier divisions is going to be 20. So it is going to be 0.05 millimeters. Okay. You can see the standard value is going to be this one, but even we can go for higher values, higher like least. I can reduce the least count going with higher number of Vernier divisions. So these are called extended Vernier scales, right? And yeah, you can do like that. Okay, so we'll try some couple of questions, and you're gonna have some homeworks too. Come to the page 11 on the other side, and let's try the question 3, 1 and 2. All right. So what was the first reading? 2.3. Okay. What millimeters, right? Okay, great. So did you write the unit? Did you write the unit? Okay, great. So in the physics, it's not, you don't need to write the intermediate unit, but you should write the unit for the final answer. Otherwise, you will not given the marks, right? Okay, good, good. What's the next one? 12.3. Ah, okay, yeah, yeah, okay, good. Similarly, you can try the question 4 and question 5 as well, right? So in the question 5, you will see on the other page too, right? There are a couple of things, right? And come to the page 13. Page 13, you will see some uh, you can see some different way of giving that scale. What are those? Yeah. So we can use the same Vernier principle for the angle measurements as well, right? Usually, we can measure the angles. What's the gadget that we can use to measure the angles? You know how a protector is, right? You usually say the handbag like this. So if you can remember, we have the 0 here, then 1, 2, 3, 4, 5, and so on. We have the 10 degrees, then 20, and so on, right? So usually we are having that for each 10 degree, we have like 10 marks. So we can measure up to 1 degrees from each calibration. So if you just use the protector, the least count going to be 1 degrees, right? But let's say here in this case, you have given a zoomed version like this. Let's say it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 is there, and 16, 17, 18, 19, 20, 25, 6, 29, 20, 30, likewise given. So in this case also you can see that each 15 degrees has been divided to 15 segments. So each going to be 1 degrees, like that, right? Okay, so now we can arrange the Vernier principle, Vernier scale for this one. Tallying 0 and 0, and instead of having 15, we can choose 14 segments like this and divide it to 50 segments. Equal segments, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, fine. Like that. So then what's going to be the least count? Yeah, so you can use the same principle. The minimum value or the length of a segment in the main scale going to be 1 degree here. This gap going to be 1 degree, and divide by number of vernier divisions, and that is 15. So it is going to be 1 over 15 degrees, or else you can just convert this degrees to minutes. If you can remember, so how we can convert degrees? How many minutes are there for 1 degree? Exactly, very good. So you can write 60 minutes divide by 15, so that is going to be 4, right? So the least count you can write either it is 1 over 15 degrees, or you can convert this degrees to minutes and it's going to be just 4 minutes. If we had just this one, we can measure it up to accuracy of 1 degree, but now we can have an accuracy of 4 minutes, right? So can you read me the first reading there? You can maybe write on the same tute. Some space here, you can write it there maybe if you need. Here up or here down, whatever. Or maybe you can write in the book, wherever you like. So once you have the practice, you don't need to write the equation once and again, right? You can just do the substitution, but it's good to practice writing the equation for the beginning questions, right? Thirty, 32 minutes. Okay. 2 degrees is fine. We'll see about the tallying one. Just 1, 2, 3, 4, 5, 6. You have taken 8. 1, 2, 3, 4, 5, 6. Have you taken 8? Okay, good. So reading. There are for sure the 2 degrees has been passed. Least count is going to be 1 degree divided by 15. into 8th one it is coinciding. So you can write here, this is to be 2 degrees plus 8 over 15 degrees. So 2.8 over 15 going to be, what's the value you got? 32. Okay. So it is 2.32 degrees. Alright, great. So you can write it like this way, or else you can just write like this. Reading is going to be 2 degrees plus, it is 60 minutes divided by 15 into 8. That is coinciding. So this cancels off to 4, and 4 into 2, 32. So it's going to be 2 degrees and 32 minutes. You could write like that too. Okay, either way it's worked. I'm not sure whether let's see, 2 8 divided by 15, it's 53. Here it is 53. 8 divided by 15 going to be 53. Like it's 2 degrees plus 0.533 going on 3333 and so on, so we can write 3 degrees. So it will be 2.53 degrees. So this is in also degrees. Or else you can convert this 1 degree to 60 minutes and you can write like this. Either way it works. Right? Got it? Great. Similarly, you can try the other questions given as well on the page 13, the upper ones, right? You just don't do the following figure shows that question, the orientation of the main scale and the vernier scale, right? Don't do that question. Up to now, up to there, you can try all the questions starting from the page 10 as homework. Maybe you can mark it on the tute. You can circle them. Once you finish a question, you can put a tick, right? You can maybe circle on the question number if you like, right? Like that. And once you do a question, you can mark it to be correct and gives the confidence, okay, I have done this much of questions, and also shows that, okay, these parts are remaining to try, right? So at the very end of this tute, you can see the answers are given as well for each and every question, right? At the very end. So unlike the scholarships, I don't need to like staple this one because I remember like for the scholarships when we are looking at the answers, we just given the parents are given to be stapling the answers. But this is A level, so you can try your question by yourself and see the answers. If it's incorrect, you can try once again. And if it is not even you are getting the answer, just post me, right? So you can just put me WhatsApp. I can solve it to you before the class, right? And there are a couple of MCQs as well you can try. So you can come to the page 27. Not much, but you can do a couple of 27. So in the A levels, same as the O levels, we will given MCQs as well. So how many choices can you see in these questions? 5 choices. For the O levels, we have just 4 choices. For the A levels, we're gonna have 5 choices, right? Okay. So for like until the next week, you can try the question 47. You can circle or maybe put a mark there. 47 MCQ. 47 and 51. Come to the other page. 52. 55 and 62. Alright, so those are the questions that you can try. just few MCQ plus some essay questions, right? So the next day we're gonna learn about the Vernier caliper and the other measuring instrument, the micrometer screw gauge. So Vernier caliper uses this Vernier principle. Now we got to know about the Vernier principle. And the next day we're gonna learn about how we can apply this to a measuring instrument and how we can take some measurements. So we need to be mastered with the Vernier principle, and that's why I given you some of the questions to try at home. Right? Okay. So with that being said, we can wind up for today. Right? So going to be usually Mondays morning from 9 to 12. So this week Monday was the holiday, so I have shifted the class to the Wednesday. Right? Are you okay with the Monday morning? Great. So if you are not being able to attend to the class, maybe like you are sick or maybe you went somewhere, just let me know. There will be the recording always. You can watch it. And even you have some doubts after the class also, the recording will be available via YouTube, so you can watch it. Right? Maybe sometimes you go home and you get, oh, how this came. Right? In that case, you can just go to the class and take the recording and you can just rewind backwards and see where the doubts that you have. And yeah, that's how it works. And you're gonna have some plenty of these kinds of tubes for each and every lesson. This is the very first tube that you're obtaining, and that's the tube only for the first lesson. For the second lesson, that's going to be the giant in the syllabus because we have seen that it's 110 periods for the mechanics. You're going to have a whole lot of tubes for that one. And yeah, we're going to do some practical nights. Night classes will be there at the very end, like closer to the exams. Some revision tests going on, the papers, and we're going to go some batch trips as well eventually. Uh, yeah, that's how it works. So we can go very chilled and also same time doing much work. So I really impressed with your like simplification and the ability to like get the concepts very well. I hope I'm trying my best to deliver the concepts to you to be getting absorbed very much, right? So if you have any friends, you can ask them to join too, and we'll see you on the next day.